Hello guys, today we'll be talking about Boolean algebra, and there's a equation that we need to simplify using Boolean algebra. I'm going to walk you through that, and I'll also show you all the rules of Boolean algebra so that you can use them to solve problems in the future. So let's get into it. So we'll be talking about Boolean algebra. So the equation that we need to reduce is this. Just gonna write it AC BA BB BC CA CB CC times A B and C. Okay, so first I'll just talk you through the rules of Boolean algebra. So first one is anything in an OR gate with 0 will be in itself, and anything in an OR gate with 1 will be 1, because if you look at an OR gate, if there's only one input with 1, then the entire thing becomes 1. Then the output is always 1. However, it's the difference. If anything is in an AND gate with 0, then it's 0 automatically. And I'm not going to explain all of this because some of them are pretty self-explanatory, and I'll just explain the ones that are confusing. So anything in an AND gate with the not of itself is going to be 0, because if you think about it, if A is 0, then the not of it will be 1, and if there's only one input with a 0 in an AND gate, if there's only one in an AND gate, even if there's only one input with a 0 as the input in an AND gate, the output will always be 0. So that's the thing. So and this is the last one. So this one's pretty confusing as well. So A plus AB equals to A. This is true because you can take A in common, and then that'll be 1 or B, and anything in an OR gate with 1 will be 1, so that will just be 1, right? So which is A, so that's equal. So that's why that works. So these are the rules, the important rules of the Boolean algebra. Now let's just get into solving the actual equation that we've been. Okay, so now we will solve the problem, the equation that we've been given, which was AC BA BB BC CA CC. Oh no, sorry. CB and CC. So that becomes AA. That will be B. That will be C. And everything else will be the same. Because as we talked about before, here, anything in an AND gate with itself will be itself, so that's why those three go away. So now what we can do is we can take this in common. We just took A in common for these two, and then we can just write AC, and then we can take B in common for these two, and then that'll be A plus 1, and then we can take and then we can just write BC, and then we can take C here common from this and that. So that will be A plus 1 plus CB. Okay, so anything in an OR gate with 1 will be 1. As you can see, we talked about here. A plus, yeah. Anything in an OR gate with 1 will be 1. So that just becomes 1. That just becomes A. And that's AC plus that just becomes 1 as well. So that's B plus so that, and then that just becomes 1 again. So plus C plus CB. Now we can take A in common in these two. 1 plus C plus, we can take B common in these two. That'll be 1 plus 1 in an OR gate with C. Yeah, and then here again 1 B. So again that'll be 1, and then that will just be 1 here again, and that will also be 1 here again. So see, and then we also have the other part of the equation left, which I didn't copy, which I didn't write it down here, but that was A. So so if you look at it, all of this entire thing is an AND gate with this entire thing, and which means we can just do if, let's say, we assume A plus B plus C as X, right? So that would be so this would be also X, this will be also X. So anything in an AND gate with itself will just be that. So we can just use X. So the answer will be X, and if we plug it back in, X is A plus or A or B or C. So that's the answer for the equation that we've been given through the Boolean algebra.